You ever wonder if we could actually reverse blindness? I mean, not just treat it, but literally restore sight to someone who's lost it. Well, today, we're diving into some pretty mind-blowing technology that's doing just that by hacking the human brain to help people see again.
This quote really gets to the heart of it, doesn't it? We're living in a time where stuff that sounded like a futuristic movie is actually happening. And we're not talking about some far-off theory. This is happening right now in labs and clinics with real people.
So how exactly is this science fiction becoming a reality? Well, it starts with one of the most ambitious ideas you can imagine, going straight to the source, the brain itself.
The first major approach is maybe the most direct, and it's a bold one: hacking the visual cortex. And get this, a groundbreaking trial in Spain just showed how powerful this can be. A woman who had been blind for more than 16 years started to perceive shapes, letters. She could even recognize a simple video game. It's incredible.
So, what is the visual cortex? Think of it as Vision HQ, inside your brain. It's the part that takes all the electrical signals from your eyes and turns them into the pictures you see. So scientists had this wild idea. What if we could just skip the eyes altogether and send signals directly to this spot?
And here's the breakdown of how it actually works. First, a camera captures what's going on in the world. Then, a little device translates that image into electrical signals. And finally, an implant with almost 100 tiny microelectrodes stimulates the visual cortex. For the patient, this created flashes of light that her brain actually learned to interpret as meaningful shapes and even motion.
And this is the really cool part. The brain isn't just a passive receiver here. It's actively learning and adapting to these new signals. It's almost like being taught a brand new language, but instead of words, the alphabet is made of light and shapes. The brain has to figure out what all these new patterns mean.
But, hacking the brain directly, that's not the only game in town. There's another approach that gives patients a new lens on life by working with the eye, using something called a retinal implant. Okay, so let's put these two strategies side by side. Brain implants, which we just talked about, skip the eye completely and go right to the brain. Retinal implants, on the other hand, place a tiny chip under the retina. It basically acts like an artificial photoreceptor, turning light into the electrical signals the damaged part of the eye can't handle anymore.
And do they work? Oh yeah, the results are real. In a big European trial with 38 patients, the average person regained about 5 lines of vision on an eye chart. Now, 5 lines might not sound like a huge number, but just think about what that means. That can be the difference between seeing nothing and being able to read letters, see a street sign, or recognize the face of someone you love. It's life-changing.
I love this analogy. Think of vision like a broken puzzle. A retinal implant doesn't magically restore every single missing piece of the image. What it does is reconnect just enough of the important pieces for the brain to do what it does best: fill in the blanks and create a meaningful whole picture again.
So whether we're talking about an implant in the brain or one in the retina, both of these amazing technologies rely on the same secret weapon: the incredible, unbelievable power of the brain itself.
Which brings us to the really big question, right? After years, maybe even decades of getting no visual info, how does that part of the brain just switch back on? Well, the answer is one of the coolest features of our own biology.
The secret is one incredible word: neuroplasticity. This is basically the brain's superpower. It's the ability to rewire and reorganize itself. Your brain isn't some fixed, rigid thing, it's adaptable. Even after years of being dormant, the visual cortex can still form new connections and learn totally new tasks, like how to see with signals from an implant. Here's a pretty good way to think about it. Imagine an old computer drive that you haven't used for years. The drive isn't broken, it's just sleeping. If you give it a new power source and the right kind of software, in this case the implant, you can bring it right back online. That's more or less what's happening inside the brain.
So what we're seeing now is already astonishing, but honestly, this is just the beginning. So where does this technology go from here? What's the next big thing on the horizon?
Well, projects like Blindsight are aiming even higher. This initiative wants to stream visual data directly into the brain, completely bypassing damaged optic nerves. And this isn't just some pipe dream. The FDA has already given it breakthrough device status, which is a huge deal. It means they see massive potential here.
Now, we've got to be realistic here. The very first versions of this tech are probably going to produce pretty low-resolution images. One expert even compared them to Atari graphics. But hey, think about the difference between an old Atari game and the photorealistic games we have today. That's the kind of leap we could be looking at for this technology down the road.
But at the end of the day, this isn't really just about the cool tech. It's about what it means for people.
It's about giving someone back their independence, restoring their confidence, and letting them get back to parts of their life they thought were gone for good. This is science that is fundamentally redefining what's possible for a human being.
So as we stand here looking at this incredible new frontier, where we can literally give sight back to the blind, it just leaves you with one final powerful question. As science keeps making the impossible possible, what on earth will we redefine next?